Welcome back to week 2 and a final video, video 3. We will talk about temperature variations and how they change by location and over time, and then what determines these variations. So the main things we're going to talk about in terms of temperature variations include how the surface air temperature changes with latitude, elevation, time of day, season, and then how these steeply and seasonal variations change in proximity to the ocean. So if we take a look at temperature and elevation, so if you were to travel from say Hood River and travel up to the top of Mount Hood, you're going to see a general decrease in the air temperature, usually in general. So we have, as we get higher elevation, we get colder temperatures. Sometimes there's a variation in that, so we have an inversion. We had this winter of 2003, where we had cold air that was trapped at the Earth's surface because it's cooler than the air above it, so it's more dense. And what happens is we end up, in the case of winter 2003 in Hood River, we had a lot of moisture in the air, which when you have the cooler temperatures, that moisture in the air then could actually crystallize and deposit on features like trees, bushes, barbed wire fences, so on and so forth. So if those of you that live in Hood River and in the Columbia River Gorge, you know that in the springtime especially, we can get cold air trapped in the valley on the surface of the earth, which is very bad for the local orchards. So what you see in the orchards are things called smudge pots, which the farmers will light those, heat up some air, and try to get convection developing so that that cold air doesn't stay trapped. They also turn on big fans that look kind of like windmills, but they're not. They're fans to try to move air around instead of having it stay stagnant. So it kind of helps to break that cycle of cold air sinking towards the surface and ruining a potential crop. So we have temperature changes with latitude and season. In general, we have warmer temperatures near the equator, cooler temperatures near the poles. We're going to take a look at this GeoAtlas program in a minute here. And while we're there, we'll also look at temperature and seasons as well. So how do you get to GeoAtlas is the question. So if you go to our course site, and you scroll to additional resources and websites, click on that link, you will see a whole bunch of information. So scroll down, you'll see this online interactive media. So you're going to be required to enter a username and password that are listed here, and then you will end up clicking on the GeoAtlas link. You also have GeoCycle and GeoAtlas of the Pacific Northwest. So a couple different things you can check out, all put together by Frank Granshaw. Thank you, Frank. So once you click on that GeoAtlas, you should see this pop up. So you'll click anything green, just like your discussions, you can click on. We are going to look at the map in this case. So here is our map of the Earth from space. And then there's lots of different items that we can click on over here in the corner. So what we want to look at are we're going to go down here to atmosphere, and we will click on in the air temperature section. We'll look at the winter temperatures of the globe, and if you would like to click on this bar, then you'll see the different numbers pop up. It might be easier to view. You can click on it again to make it go away. So this is showing you the average surface air temperature in the winter in the northern hemisphere. So if you notice, equator right in the center is much warmer than the poles, and that makes sense because this is where we're going to have more sun focused on the Earth's surface. So we have that beam of light isn't getting spread out as it does at the poles. It's more direct at the equator. So this is our variations with latitude. As we get to higher latitudes, closer to the North Pole, closer to 90 degrees, we end up with cooler temperatures. The other thing to notice is change in temperature with seasons. So I'm going to click on summer temperatures, and we see summer in the northern hemisphere, we end up with more warm temperatures in our northern hemisphere. So if we go back here to winter in the northern hemisphere, we see we have blues up here in Canada, Greenland, and northern Russia, Siberia. If we click on summer, we see we don't see any blues. We have much warmer temperatures because the northern hemisphere is tilted towards the sun. So you see an overall temperature change. So that's our temperature change with season. We also see a temperature change with the time of day. Here we have a graph of the temperatures in Hood River over 24 hours. So right now when I'm filming this, it's about 3:30. And then if we go back, we see this darker gray area. This is going to be nighttime. Overall, we see a decrease in temperature at night. Coolest temperatures are right before sunrise, and we see an increase in temperature during the day. And this is because the sun is hitting the earth, warming up the air, and causing the temperature to rise. Now, if we were to look at the weekly temperature change in Hood River, we see the first few days of the week, we see a very high variation. So the blue line is going to be temperature. It's the one we want to focus on. So high variations in the highs and the lows each day. But then when we get to around the first, second, third, we see a very low variation, and we have about the third, fourth larger variation, and back down to smaller variation. One thing to note, on the fourth and the fifth, we look at our precip data, we know it's rain, so we have cloud cover here, which is probably the case for these other days where there's very little variation. So what happens is you have a cloud cover coming in, kind of blanketing the earth and causing any warm temperatures that could possibly be caused by increased solar radiation from the sun. Those clouds are blocking them, but also those clouds are also trapping the heat that had just reached the surface. So we have more of a leveling out of our temperatures during those cloudy days. And we can also look at changes in monthly temperature variations. You can see we have April and March were pretty interesting. A decrease here towards the mid-end of March, and then warmed up towards getting into April. When we look at yearly variations, we see makes sense. In June, July, August, September, we have much warmer temperatures, getting up into the 80s and 90s, and then when we go down into the winter months, January, February, we end up with cooler temperatures. And that makes sense because the northern hemisphere is tilted away from the sun in winter and then towards the sun in the summer. So that's why we see that variation in temperature through the seasons. And here's just a diagram showing you what happens during our cloudy days, when we have warmer temperatures at night, or more leveling of our temperature highs and lows, because we have those clouds trapping that heat energy. So we also see a variation in temperature in proximity to oceans. So, and also breezes that can develop. So in the daytime, we have the warm air, the sun striking the land, heats up, warm air above warms, rises, and then we end up with sinking over the oceans, and then we get this overall circulation pattern, and we get a sea breeze on the coast. The nighttime, things switch. The ocean has been warming up all day. Now it is cooling down. We have this surface being warmer than the land because the land cools much faster, the lower heat capacity. So it's going to hold on to that heat not as well as the water will. Water will hold on to heat a lot longer, and so we end up with a land breeze that develops. So places that are closer to the water, because of this high heat capacity of water, end up being more mild as far as temperature change. So if we look here, go back to our winter temperatures, those places that are close to the ocean tend to have a different, more variation, or less variation in temperature. So if you go to the Oregon coast, we see that the temperatures are more moderate. We don't see the high extremes or the low extremes as we see further in the center of the continent. So if you look at Australia here, very far, the center of the country is far from the ocean, so we see higher variations. And then up here in the inland part of Russia, Siberia, you see it gets very cold and very far from the coast, and in the summertime it can get warmer as well because it's far away from the water. So the water kind of has this cooling effect. So causes for temperature variation, like we just discussed in the last few slides, and the main causes are latitude, surface type, so do you have pavement, do you have grass, do you have ice, do you have water, elevation, so higher elevation, cooler temperatures, and albedo kind of relates back to surface type, how much of that energy is going to be reflected away from the surface. Ocean currents, those ocean currents, if we look at our GeoAtlas again, if we look here on the west coast of South America, we see this cool ocean current that comes up and flows to the north. It's bringing cooler temperatures up the coast. And if we look here on the east coast of the US, opposites happening, warmer temperatures being brought up to the north, which we might be able to see a little bit better here. So the jet stream comes up and over and brings this warm air and water to northern latitudes. And then the proximity to oceans. Our daily seasonal changes are due to changes sun angle, length of the day, and cloud cover. So that wraps up our temperature variations. So check your textbook for more details, and I will see you in lab.